This lesson deals with supplemental problem 312. You can find this problem in the course ebook in the Chapter 3 Supplemental Problems on page 15. Given a circuit, which contains 3 resistors, an independent current source, and a dependent current source, can you solve for the node voltage V1 using the node voltage method? This is a 5-step algorithm in our class notes. Steps 1 and 2 are to pick a ground node and then define the nodes. That's already been done for us. Step 3 is to do Kirchhoff's current law, and for us to do that we need to assign a current in each element. Arbitrarily pick this current to be I4, I2, and I16. Doesn't make a difference how you pick it, just stick with it throughout the problem. The current that enters the node is 4 amps. What's leaving is I4, I2, and V1 over 4. But every current in our circuit can be related to the node voltages, so let's do that. With this direction of current, we're implying by Ohm's law that the drop is this way, which is going to be node voltage 1 minus 0, or just V1, divided by 4. Current in this direction implies a drop this way of V1 minus V2 divided by 2. And lastly, we have V1 over 4. I have one equation and 2 unknown node voltages, V1 and V2. Let's group them together. So here's V1 with a quarter, a half, and a quarter. And then I have V2 with just a minus a half. Quarter plus a half plus a quarter is just equal to 1. And of course, this is minus a half times V2. So one equation, 2 unknowns, that equals 4. Do the same thing at node 2. What's entering is I2, V1 over 4, and what's leaving is I16. I2 is V1 minus V2 divided by 2. V1 divided by 4 is the controlled source. And then because of this direction of current, applies the voltage this way by Ohm's law, we have V2 minus 0, or just V2 divided by 16. Since I have V1 and V2 in every expression, let's put all that on the other side of the equation. 0 is going to be equal to V1 times a minus a half, V1 times minus a quarter, minus V2 over 2 will become a plus V2 over 2, so 1 half V2, and then 1 over 16 times V2. Half plus a quarter is 3 quarters, so minus 3 quarters. And then these two together are 0.5625 times V2. And 2 equations, 2 unknowns. In matrix form, we have that 4 is equal to 1 times V1 minus a half times V2. Our second equation, we have 0 is equal to minus 0.75 times V1 plus 0.5625 times V2. I'm going to solve for V1. Using Cramer's rule, we'll take a ratio of 2 determinants. We'll take this matrix right here, find its determinant. That'll be our denominator. The numerator will be this same matrix with replaced by the left-hand side of the equation because that's the column associated with V1, so 4 and 0. So this times this minus this times this is the determinant. This times this is 2.25 minus 0, and then this times this is 0.5625, and then minus the product of these two minuses still gives me a negative, but 0.375. That gives me a ratio of 12. And this is supplemental problem 312.